Okay, so Justin asked me a question because he said he didn't know how to properly set up a cam file for fourth axis programming. So go ahead and do that, show how to do that. So just starting with a new milling file, cancel this. Starting from a CAD model, you go ahead and import a v411 initiate xt file. So there we go. Then you just follow this wizard. Align Z with the center revolved surface. So you want to figure out where you want your z-axis to be for your A0. Just pick revolved surface. I like to pick the switch hole. I'm going to have to put the phone down for a second to rotate the view. Now I can pick up the hole, but it has my z-axis down here in the corner going down through the part. I want my A0 to be at the switch hole. Go ahead and do that. And then here, I like to just rotate normal too. And right now my x-axis is going this direction, so I need to rotate it 3 times so that my x-axis is going this direction, because it sits on the collet on this end and x positive is over there. Just going through some basics. Round stock along the x-axis. Next, and then it automatically computes it for the center, where the center point of the stock should be. And then if you just compute stock, because we're not doing any turning or anything like that, machining the lengths, I just have it automatically compute all of the information. Set your location for your X, or for your work offset on this side, on the collet end, not over here, but over here. And fourth axis positioning, index around stock x-axis because it rotates around the x. Next, and then finish. So now we're ready to go. Basically, the tricks with fourth axis programming is everything has to be programmed at A0 in terms of two-dimensional geometry. So you can create your two-dimensional geometry in the normal way. I'm not going to get into that here, but it has to be at A0. So if you have a feature that is not at A0 that you're trying to generate 2D geometry for, all you have to do is go into your work offset here, double click on your UCS and say rotate about your x-axis to the A0 point for that feature. Do your programming, and then after you're done with that, you just re-rotate your work offset back to the original A0 where you want it to be. That's how I do it. If you use feature recognition for some features, it will automatically pick up your A rotation. Like for holes and things like that, it'll do that. But if it's like a milled feature, like a side or a pocket or a boss, I've found that you're better off just rotating the work offset, doing it two-dimensionally, and then rotating your work offset back, and then it maintains the location of that feature along the A-axis. Don't have any examples of it on this part because this one feature is on A0 and it gets rotated, and this one is also on A0. Rotated meaning a circular pattern around the part. The only other feature is the drilled and tapped hole up here, but that is one that you can automatically pick your A value, or have it automatically generate your A value by using the feature recognition. I'll just do that one right now, extract with feature recognition around the index axis, and then automatic, and then click next, and then recognize multiple holes, and then you just pick your hole per normal, and then finish, and then you just change your hole parameters to be your drilled and tapped hole, defining the size of your countersink, etc. So yeah, that's the only one, that's the easiest one. And then if you look in the code for that one, well, it's going to give errors because countersinks were wrong on it. So let's change it just to our tapped hole, and 136, 32 thread depth will be 250, thread depth will be 230. It'll alarm out if your thread depth is less than your total depth, and then we're good there to at least show what I'm trying to show, that your A will be at 180 degrees for that feature. And yeah, so holes, it's simple for quick and easy feature recognition. For milled features, bosses and pockets, it's easiest to index to that A value by rotating your work offset and drawing it up in 2D and then finishing it that way.